As shown in the figure, a block of mass 10 kilogram lying on a horizontal surface is pulled by a force acting at angle 30 degree, mu as being 0.25. Just start to move for the value. The block will just start to move for the value. Okay. See, this question, I would take this as an opportunity to discuss further on static friction and kinetic friction. So, those who want to have the direct answer, you have it over here, right? So, basically, what I've done is I've visualized the situation, I've drawn the free body diagram, resolved the forces into horizontal and the vertical ones, given the logic for the resolution here. So basically this becomes from this triangle you can resolve a vector f into two components, one horizontal and other vertical, horizontal force and the vertical force, and you can find out the component using this triangle ABC, where sine theta will be equal to BC by AC and cos theta will be equal to AB by AC, and you have the formula. So what is BC? BC will be equal to F sine theta, and what will be AB? AB will be equal to F cos theta. Then you can apply sigma Fy is equal to 0 and then sigma Fx equal to MA, and then you have the answer. Okay. So, yeah, those who don't want to go for the in-depth explanation of static friction, you have the answer here. This is it. The complete values is being derived here. However, if you want to understand static friction in a bit more detail, which I suggest you should do, because that will really help you in developing your concepts. So I'll say the definition of limiting friction, and then we'll go into see what is static friction. Okay. So what is limiting friction? It is defined as the maximum frictional force. Mind you, it's the maximum frictional force that needs to be overcome to initiate motion. It acts when a body is just about to move or slide across the surface of another body, just about to move, okay? And directly proportional to the normal reaction. So what is this we're talking about? We're talking about limiting friction. So the key points that we need to understand here is that limiting friction is actually the maximum friction value, okay? And it comes into picture when the object is just about to move. Okay, now let me take you through an example where there is an object of 1 kilogram mass, F external is acting towards the right, and we know that static friction will oppose the motion, right? And we have normal reaction and mg. So since the object is restricted along the x-axis, along the y-axis there is no motion, so we can write that sigma Fy is equal to 0. Now you may ask me how. See, since there is no motion along the y-axis, I can say that displacement along y-axis is 0. Therefore, velocity along y-axis is 0. Therefore, acceleration along y-axis is 0. And therefore, m into ay will be equal to 0, which implies Fy, which is m into ay, is equal to 0. Therefore, sum of all the forces acting in the y direction, sigma Fy, will also be equal to 0. Now, what does it mean when we say sigma Fy is equal to 0? It means that forces acting along the up direction will be equal to forces acting along the down direction. Now, which are the forces acting along the up direction? There's only one, which is normal reaction. So we have normal reaction. Forces acting in the down direction, there's only one force acting on the down direction, which is mg. So we have n is equal to mg. Now, by laws of friction, what do we have the value of static friction as is equal to mu s into n? Assuming that the mu s value is 0.1, we have static friction is equal to 0.1 into m into g. And therefore, static friction is equal to 0.1 into m is 1 kilogram into g is 10. So 10 is 100, 100 to 0.1 is 10 Newton. Now, this is where most of the students make a mistake. Why? This is not actually static friction. Then what is it? What we have here is the maximum value of static friction. What we have here is the maximum value of static friction. What we have here is the maximum value of static friction. Now, is that word familiar? Exactly. When we say the maximum frictional value, this expression is actually what we found it as the limiting friction. So what is the value of limiting friction? The limiting friction value here is 10 Newton. All right. So when we say mu s into n, we are not talking about static friction. Instead, we're talking about maximum value of static friction, which is actually the limiting friction, and therefore the value of limiting friction here is equal to 10 Newton. All right. Okay. See, now Once the body has started moving, okay, now I don't want to go much on kinetic friction here. We will reserve that discussion to a separate section. Okay. All I want to tell you is generally, static friction, the value is higher, and kinetic friction, the value is lower. So static friction value is greater than kinetic friction. Why? It is very hard to let us say, if you just assume this block to be a car, okay, block to be a car. It is hard to push a car from rest, but it is hard to push a car from rest. But once it has started it has gained some motion, it has gained some velocity, it is easy to push the car, right? And therefore the kinetic friction will be less while it is moving, and static friction will be more as it is at rest. Now we will definitely go through the kinetic friction in detail, but not in this question. So let us come back to our the concept that we were interested in. So I hope you have understood about. Oops, my bad. The value of limiting friction, right? Now, if you understood the value of limiting friction, let us take some time to understand the concept of static friction here. So we have the same example. There is F external acting here, and there is static friction opposing it. Now this time I mean static friction and not the maximum value of static friction. So what are we trying to do here? We're trying to understand the significance of F external. We're talking about the significance of the net force and not the static friction. Okay, why? Because F net is actually dependent on both F external and the static friction. Let's see how. So this might be a little bit confusing. Maybe you'll have to go through the explanation a couple of times and write it down on your own and explain it to yourself to get a better picture on it. Anyway, I'll try my best here. So there is a body of 1 kilogram mass, right? How many forces are acting along it? As we said, sigma Fy is equal to 0. So I'm not going to consider about the normal reaction and the weight here. We'll be discussing only about F external and static friction. Okay. So static friction will oppose the motion. F external will try to induce the motion, right? Maybe I'll just write it over here. Static friction will oppose the motion, whereas F external will induce the motion. So what is the value of static friction? That's what the point of discussion here. So I can write here that F net is actually the difference of F external and static friction, right? F net is the difference of F external and static friction. The signs is something that we can discuss later. Let me just say this is the difference of F external and static friction. Okay. Now please pay your maximum attention here. When the F external is 0, which means when there is no force acting on this body here. Okay, when there is no force acting on this body, the body is at rest, right? Therefore, static friction is also at rest. Now, from the previous discussion, we have here that the value of static friction. Oh my bad. So the value of limiting friction here is 10 Newton, right? The value of limiting friction is 10 Newton. So I'll make use of that reference here. The maximum value of static friction is 10 Newton, right? Or otherwise, friction limiting is equal to 10 Newton. Okay. So in the first case, what is the value of static friction? Okay, maybe you will understand better when I write down things along with this. Now you may say that the maximum value of static friction is 10 and therefore the value here should be 10. No, the value here is 0. And what is F net? The difference between F external and SF, which is 0 minus 0, 0. Okay. Now let's see, if I increase the value of F external to 2 newtons, what will be the static friction now? What is the maximum value of static friction? The maximum value of static friction is 10. So you will always check this condition. What is the value of F external? And then you'll compare that with limiting friction. If the value of F external is less than limiting friction, then the value of F external will be that of the static friction. Okay, let's see that one more time. F external, if that value is less than limiting friction, then the value of static friction will actually be the value of the F external. We have doubt? We'll make it clear. What is the applied external force here? 2 Newton. So 2 Newton is less than 10 Newton, right? Therefore, what will be the value of static friction? It will be equal to F external, which in this case is 2 Newtons, right? Which in this case is 2 Newton. Therefore, what is F net? F net is difference between F external and F static friction. 2 minus 2 is 0, right? Okay. You have doubt? We'll take a couple of more examples. Let us increase the value of F external to 4 Newton. Now, if the value of F external is 4 Newton, substitute it over here. F external is 4. What is the maximum limit? It is 10. 4 is less than 10, right? 4 is less than 10, and since 4 is less than 10, we can say that static friction in the value is equal to F external, and therefore the value of F static friction here would be 4 Newton, and we can say that F net will again be 4 minus 4, which is equal to 0, right? Now, if F net is equal to 0, what does it mean? It means that the velocity acceleration of the body is 0, which means velocity of the body is either constant or it is 0, right? So the body may, in this condition, the body may tend to be in rest. Let us increase the F external. Now this is 6 Newton. 6 again is less than 10. And since 6 is less than 10, we can say that static friction will be equal to the F external. And therefore, here as well, we have the value of static friction to be 6 Newton. Therefore, F net will be difference of these two, 6 minus 6 equal to 0. 8 Newton, again, you'll get the static friction to be 8, and therefore the net force will be equal to 0. Now, when static friction is equal to the maximum value, we say when the static friction is equal to the maximum value, then although the net force here is 0, the body will tend to move. Why so? See, that is what we were discussing the very first term here. The body is just about to move or slide. The body is just about to move or slide when the maximum value of frictional force is attained. So what is the maximum value of frictional force here? The maximum value of frictional force here is 10 Newton, and therefore in this condition the body will tend to move. What happens prior to that? During all these conditions, the body will be at rest. Now let's try to understand what happens after this. Now, if the F external is 12 Newton, the condition here reverses. What does it become? It becomes F external is greater than limiting friction, and when F external is greater than limiting friction, this condition is readily violated, right? And what happens to the static friction now? The static friction now becomes what? Can you make a guess? The static friction now becomes 0. But what happens to the F net? F net remains the same. Why? Because F net is the difference between these two. So 12 minus 0, now what we get is, we get acceleration here, right? What we get is 12 minus 0 as 12. No. Why? Because we also have something called as kinetic friction. Say in this case, for example, is 9 Newton. Now, since the body is moving after this condition, the body has started to move. So rest tends to move, and then it moves. When it starts to move, which friction will come into picture? Kinetic friction will come into picture. And when kinetic friction comes into picture, we will have to include that value here. So this time the net value will be F external minus, instead of static friction, we have kinetic friction, and therefore 12 minus 9, what we get is some value 3. Okay. Now, kinetic friction remains constant. Why? Because it is not a self-adjusting force, whereas static friction is a self-adjusting force, and that is why you see the value being adjusted like this. Okay. Now, next case, kinetic friction remains 9. 14 minus 9 you get is 5 Newton, and therefore there is some F net, and therefore definitely there will be an acceleration. The body is in motion. Static friction again remains 0, but kinetic friction takes up, and once kinetic friction is overcome by F external, there will be motion in the body. Okay, which otherwise means that all these values here, as you said, will have to be how much? Yep, it has to be 0, because the object was in rest, and therefore during the condition when the object was in rest, kinetic friction value will be 0, and when the object is in motion, the kinetic friction will come into picture, but the static friction would be 0. Okay, so that's the point here. That's the concept here. So let me just summarize these things. So block will tend to move when F external is equal to maximum value of, not SF, will be the maximum value of static friction, or in other words, which is equal to the limiting friction. Block will move freely when F external is greater than kinetic friction. Block will be at rest when static friction is greater than F external. Okay, so that's the concept behind static friction. Now let us come back to the question here. So what does the question say? The question says that the body is just start to move. In which case, which friction do we have here? Is it static friction or kinetic friction? It is definitely not static friction, kinetic friction. It has to be static friction. Now the force is applied at an angle 30 degree. So let us first resolve the force, right? Let us first resolve the force. How do we resolve the force? We will resolve the force to go in two directions. One would be the horizontal direction like this. The other would be the vertical direction like this. And then you can replace this vector from here, right? You can replace this vector from here and keep it over here, right? And therefore what essentially we get here is we can draw this as a triangle with one vector like this and the other vector like this, horizontal and the vertical components. And if you complete this triangle ABC, what is sine theta from here? Sine theta will be opposite, which is BC, by adjacent, which is by hypotenuse, which is AC, and the magnitude of hypotenuse is AC is F. Therefore, what is BC? BC will be AC sine theta. BC is AC sine theta. AC is F. Therefore, BC equal to F sine theta. Similarly, we can write that AB is F cos theta. Right? The value of theta is 30 degree. Okay. After that, we come back to the free body diagram. When we have the free body diagram, how many horizontal forces are acting here? Static friction is acting towards left. The F external is acting in horizontal and vertical direction. We found out to be F cos theta and F sin theta. Vertically, we have mg and n. Now, since Fy is equal to 0, we can write that sum of, okay, what does Fy is equal to 0 imply? It implies that forces, sum of forces acting in the up direction will be equal to sum of forces acting in the down direction. So along the positive y axis, right, along the, or say the north facing forces, we have two direction, we have two forces. One is normal reaction and F sine 30. So sigma ff means we'll have to add these two. So we have F sine 30 plus 9 is equal to sum of forces in down direction. There is only one force which is acting in down direction, which is mg. So we have F sine 30 plus n is equal to mg. All right. Now, most of the students assume here that the body is in equilibrium, and therefore SF is equal to F cos 30. No. It is not the case. The case here is, since the body is just start moving, to move, what can we say? The value of static friction here would be the limiting friction, which actually will be equal to the F external. And what is F external? It is F cos 30. What is the value of static friction? The maximum, sorry, my bad. This here should be the value of maximum static friction. What is the value of maximum static friction? Maximum static friction value is mu s into n. But what is n from here? N from this equation would be mg minus F sine 30, right? So instead of n here, I can write mu s into mg minus f sine 30 is equal to f into what is cos 30? It is root 3 by 2. Now, so we have mu s. What is the value of mu s? It is 0.25. My bad. The value of mu s is 0.25 into m is 10, g is 10, f sine 30. Sine 30 is 1 by 2. Algebraic manipulations. So 25 0.25 that is 25 by 100, right? Minus 10 into 10 is 100. So I'll let it as 2 into 100, 200 minus f by 2. So 25 by 100 is 1 by 4. 2 into 100 is 200 minus f by 2 is equal to cos 30 is root 3 by 2, root 3 by 2 into f, right? And further, I'll write 200 minus f is equal to, now see, 4 into 2 is 8, right? That by 2 is 4. Or maybe let me just simplify this. So 2 by 2 is 1, and then you can transpose this 4 to the RHS. So 4 will go to the RHS. What we have, 200 minus f is equal to 4 root 3 into f. 200 is equal to negative f to the RHS will give you 4 root 3 f plus f, right? If you take f common, what we have is 4 root 3 plus 1. So 200 is equal to 4 root 3 plus 1 into f. Therefore, what is f? F is therefore equal to 200 by 4 root 3 plus 1. Now, how would you simplify this? See, now we can directly go into the options and eliminate if you want to, but I would say to be on the safer side, just spend a couple of more time, maybe not a couple of seconds, maybe 10 or 20 seconds more. What's the value of root 3? Yes, somewhere around 1.73. So what is 1.73 into 4? You have 6.92. What is that plus 1? 7.9, which I can approximate this as 8, right? So basically what do we have? 200 by 8, which is approximately, well, okay, 200 by 8 is definitely not approximate. It's a definite value, it's 25. But since it's approximated, we approximately get this value to be closest as 25 newtons. Okay, so yes, I did take a bit longer than usual, I would say, to explain, because I wanted you to go through the concept of static friction. And see, solving this question is important. Yes, definitely yes, because ultimately that's what you wish to do. But what's even more important is to understand the concept behind it, because if you don't understand what does it mean when the question says when the question says bodies just start to move, and if you don't know that when a body is just starting to move, the maximum value of static friction becomes the limiting friction, which actually is equal to the F external, then there's that is the point, that is the concept the question is trying to evaluate on you. So that understanding that becomes really important. All right, so that's it with this question.